Hello and welcome to this video where I'm going to take you through calculations for IV infusions. So when it comes to IV infusions, the IV sets that we have, there are two. We have two main IV sets. We have one which delivers 15 drops per ml. Okay. Then we have another which delivers 20 drops per ml. Okay, so as you are giving these IV fluids, just make sure that you know which type of giving set you are using, the IV giving set that you are using. So the formula that we use to calculate for the drops per minute is drops per minute, which is equal to volume to be given multiplied by the drop factor divided by the time multiplied by 60. Okay, so this is the formula, that is the drops per minute, which is equal to volume to be given multiplied by the drop factor divided by the time multiplied by 60. Okay, so now let's look at one question. Okay, we'll look at two questions. Okay, so the first question reads, a patient requires a 1000 ml of normal saline to be infused over 8 hours. The drop factor of the IV tubing is 15 drops per ml. Calculate the drop rate per minute required to administer the infusion. Okay, so to calculate the drop rate per minute for administering the infusion, you can use the formula that we have given you, which is drops per minute divided by the volume to be given multiplied by the drop factor, then divided by time times 60. So first, let's convert the time for infusion from hours to minutes. So we've been taught that this patient requires 1000 ml of normal saline and it has to be given in 8 hours. So we're going to convert the 8 hours to minutes. So that is T times 60. So which is the time multiplied by 60, which is going to give us 480 minutes. Okay, 480 minutes. Okay, now that we've converted the time, it means when we get this formula, the drops per minute, the volume we already have, which is 1000 ml. We've been given 1000 ml multiplied by the drop factor, which is 15, divided by the time, of course, time which is in minutes, and we've already calculated as 480 minutes. So going to do that one into that, you're going to have 2.08. Okay, 2.08 mil per minute. So it should be mil per minute. So now this 2.08, you multiply it by the drop factor. So this 2.08 multiplied by 15 drops per minute, you're going to have 31.2 drops per minute. So the units for 31.2 drops per minute, that is GTT. So GTT is standing for or representing drops. So per minute. Okay. So let's go through. So when you are given such a question, try to find out what you have at that particular moment in relation to the formula. So with the question that we are given, we had the volume, which is 1000 mils. Then we had the drop factor, which was 15. Then the time we were given 8 hours, which we converted to minutes, which is 8 hours times 60. It gave us 480. Then we had to divide 1000 mils divided by 480 minutes. So this is what we did, just trying to break it down one by one. So we had 1000 mils divided by 480 minutes. Okay, so when we divided this into that, we had 2.08 mil per minute. Okay, so that is mil per minute. Okay, then we have to multiply this by 15 drops per mil. 15 drops per mil. So now drops per mil, that is GTT, then you write mil like that. So meaning the mil and the mil, they are going to do what? To cancel. Then when you multiply 15 times that, you're going to have 31.2. Then you get the drops, which is GTT per minute. Okay, so meaning for 1000 mils to run in 8 hours, we need to set the fluids to 31.2 drops per minute. So this is the first question. So the next question, let's look at the next question. So the next question is saying a boy is supposed to receive 400 mils of dextrose or 5% dextrose in 8 hours, and the IV set delivers 60 drops per minute. Sorry, per mil. Calculate the drops per minute. Okay, so remember the formula that I've already given, which is the drops per minute. The drops per minute is equal to volume to be given multiplied by the drop factor and then divided by time times 60. So now the volume we've been told is 400 mils. Okay, 400 mils. Then the drop factor, we've been told that this set delivers 60 drops per 60 drops per mil. Okay, 60 drops per mil. Alright, then the time we've been given as 8 hours. So we have everything here. Okay, we have everything there. So 8 hours already know that is 480 minutes. So now to infuse into this formula, we're going to have 400 mils times 60 drops per mil divided by 480 minutes. So from this, we're going to have 50 drops per minute. So meaning for 400 mils to run in 8 hours, and then if the drop rate has been set to 60 drops per mil, it means we need 50 drops per minute for us to achieve 400 mils. Okay, I hope you understand how these units are coming about, because I've explained on the first question on how we are coming up with these units. Everything, the procedure on how to, or the process on how to arrive to this answer. So that is all I had for you. If you have any questions, leave your questions in the comment section. Don't forget to hit the like button, subscribe if you haven't subscribed for more videos like this. See you in the next video.